Hello there, college algebra students. This is Mr. Kashi speaking. Today's lesson is about multiplying matrices. I know we've covered multiplying a matrix by a scalar, by a single number. Now we're taking two matrices and multiplying them together. So the first thing that we need to make sure is that we're able to do that. So this little diagram, which I'm pasting on all of the slides today, is a little thing to help remind you if you can do it, and then what the dimensions of the solution are going to be. So you can see matrix A. This isn't for this example, but this is just a little diagram. Matrix A is a 3 by 2, and matrix B is a 2 by 4. And so what needs to happen is these middle ones have to equal each other in order for this to be able to multiply, and then the dimensions of the solution are going to be the outside numbers. So our solution in the in the diagram would be a 3 by 4. So I do want to run through a few examples here, so let's begin. So with this first one, I just want to kind of lay out what A and B are. So A is a 2 by 2 matrix, and B is a 2 by 2 matrix. Okay, and these two are the same, so we are able to multiply these two together, and our solution is going to be a 2 by 2. And that's why I did this, the first one. When you multiply a 2 by 2 by 2 by 2, your solution is going to be a 2 by 2. It's a little bit easier to understand. Now, multiplying them gets a little tricky because you have to stay organized. So here we're going to create kind of a large one down here, and you'll see why I do that here in a sec. But what we have to do first is we have to take these numbers, and we're going to go from left to right in that first row as we go down that first column. Okay, so stay with me here, because we're going to take this first one. We have 2 times 6, and then I'm going to move right to the 9 and then go down to the 0. So plus 9 times 0. So 2 times 6 and then 9 times 0. Hopefully you can see as we slide to the right in matrix A, we're sliding down in matrix B. So now I'm going to show you we're going to slide to the right in that same row, but now we're going to go down this other column here. So here we would have 2 times negative 4 plus 9 times 3, like that. So we had the 2 times the negative 4 and the 9 times 3. Then we're going to have, this will be our matrix here. And then what we're going to do is we're going to skip down to this next row. We're going to go across here as we go down this first column. So this would be negative 7 times 6 plus 3 times 0. And then last, what we're going to do, we're going to go across the bottom again, and then we're going to go down this second column here. So this would be negative 7 times negative 4 plus 3 times 3. And then all that's left is just to kind of clean things up. So what I do is I just create a separate matrix over here, and then I just kind of go through and do my little additions here. So we have multiplications and additions. So that would be 12. This would be 0. So our top left number there would be 12. 2 times negative 4, that'd be negative 8. Plus 9 times 3, that's 27. So then that would be let's see, that would be 19 in the upper right hand corner. Down here, this would be negative 42 plus 0, so that would make this negative 42. And then here we have a positive 28. Negative 7 times negative 4, that would be positive 28. And plus 9, and that would be a 37. So it's a little bit hard to keep track of which numbers go where. Like the hardest part is to know where to put this. So like if you're to go back to these red, you see how in the first one we were to go, we hit this number and that number twice. So it's going across and then going down, And so that's how we know that it's going to be in the upper left-hand corner. This is going to take some practice, so we'll move on to our next example. So in this case, we have our matrix A, which is a 1 by 2, and B is a 2 by 3. And what this means is these two are the same, so we can multiply these two, and then our solution is going to be a 1 by 3 matrix. So let's set that matrix up here. And so here we're going to go across the row, and then we're going to go down this first column. So it's going to go 3 times 4 plus -5 times 1. And the next, we're going to go across here, and then we're going to go down the next column. So here, this would be 3 times 0 plus -5 times -3. And the last one, we're still going to go across this same row. We're going to go down the last column. So that would be a 3 times -2 plus -5 times 2. All right. So just to clean this up, this would be 12 plus -5, and if we had a solution matrix down here, this would be 7 in the first one. This would be 0 plus 15, so 15 would be in the middle one. This would be -6 plus -10, which would give us a -16. So in this case, our solution, as you can see, was supposed to be a 1 by 3 matrix, and it's a 1 by 3 matrix there. 7, 15, and -16. Moving on to our next example, once again we have our first matrix is a 2 by 2. Our second matrix, our B matrix, would be a 2 by 3. So this means that we can multiply them, and this means our solution is going to be a 2 by 3. And so we want to make sure that we kind of account for that for our space. Okay, and I'm going to run out of colors here, so I'm just going to start with black. So we're going to go across here and down there. I find it easier to color code than anything else. So we have 3 times 5 plus 4 times -6. Then the next one, I'm going to go across here still, but I'm going to go down that second column. Okay, which means that it would be right here. We'd have 3 times 2 plus 4 times 0. We're going to go across here again. I'm going to go down the last column. So here this would be 3 times -8 plus 4 times 9. We go across this second row here. We're going to go down this first column there, so that would be -7 times 5 plus 1 times -6. Next, we'll go across this bottom row and down the middle column. So we have -7 times 2 plus 1 times 0. And last one, across the bottom row again and down this last column, that would be -7 times -8 plus 1 times 9. Okay, so now we have to go back and clean things up. All right, so it's easier to just kind of do this step by step. So this would be 15 plus a -24. So that would be a -9. And I'll put our solution matrix down here. This is going to be a 2 by 3. So this would going to be -9. This is 6 plus 0, so this would be a 6 in the middle, in the top row. This would be -24 plus 36. So that would be positive 12 in the upper right-hand corner. This would be negative 35 plus a negative 6. That would be a negative 41. It would be bottom left-hand corner. This is negative 14 plus 0. It would be negative 14. And then this would be 56 plus 9. And 56 plus 9, that would be 65. So obviously it takes a little bit more work, kind of hard to keep things organized, but we did finally come up with our 2x3 solution matrix. I do have another slide. I'm not going to go through this whole problem, but there are some cases where they're just going to say, hey, I want you to square this matrix. And I won't go through the whole thing, but I think it's a lot easier just to kind of set things up and just rewrite the matrix again and multiply it out. So in this case, we would have a 2x2 and a 2x2, right? So A times A, right? So this means that we can multiply them together, and this means that our solution is going to be a 2x2 matrix. And hopefully you know now, like, this would only work if we had a square matrix to begin with. And so then I would set up and go through each one here, and it is going to be a little bit different. It's not going to be just negative 5 squared, right? Because as you go across here, you're also going down. So it's not just going to be the numbers here squared. There's more involved than what you might think to begin with. But I'll let you do that one on your own, and I will obviously be available if you have any questions.